This is my third or fourth time.
Just to catch up with.
Peter is the one that I met. Do you remember the time that Marcus said something at UQ? Inauguration of the blockchain event for the club that they had there. So I met him there actually. So,
yeah, the UQ.
October, around October it was.
Yeah.
So Uwe is my professor, he's my supervisor, and Marcus is the one that sent me the invitation to come to you, and we're working on this capital on this particular project. Yeah, that's why I always running everything on the board.
Have you been? I saw you
Yes.
Congratulations.
Thank you. It's awesome. It's amazing. As I was saying in this talk, it's a collaboration of people. It's put Harkin in a new era, a blockchain, and international blockchain. It's taken us into a little bit, it's technology is now
Exciting stuff.
So we're live on YouTube again, and so why don't I should introduce you
You want to start?
no, what we'll do is we'll just do an introduction for those people who just can't jump on the live stream. And so, what we'll do is, I've actually checked out video a few times. I think I've got it now.
Yeah, no, that's right.
Oh, that's good, that's good. So what's going to tell us about this?
Talking to my when I started to look at blockchain as technology, there's this great story that it almost like to tell blockchain, how blockchain came about, more full nets. So I just highlight why I'm speaking going live there. And I was all the research ideas was very early stages.
We're live on YouTube, and so just a second, we're going to do that, and otherwise we're going to lose that. And yes, so do you want to introduce yourself, and also, so what are you going to talk about today, and who are you?
So, my name is Behavioural. I'm a lecturer at the Queensland University of Technology. First of all, I'm very pleased to be here. My main focus in my research conviction is about international business and digitalization of international business. And a little bit of strategy. However, today the topic is going to be much more related to economics, because I think the fundamentals of blockchain has been changing our perception of markets and internationalization. We have so that's going to be
Okay, well that sounds really interesting too. Golly. Alright, well that's good. And so I'm the third speaker, and I'm going to talk about blockchain technology. So the meetup itself will start in about 10 more minutes. So yeah. Okay, so essentially, my concept is that if anyone's not actually joining the live stream, like look at it and go, alright, well this is what to expect, and we are on the right place. microphone that is
Do you have a peak change?
no, the best thing is just forward and back.
Maybe out of this. Will they see the screen or will they see the slides?
So what we're going to do is we'll zoom like those, and that will zoom in just there. And so yes, you're right. If we were to move this all over here just a little bit, then we should be able to talk and go left and right. And that, as you can see, is live. With my water that way.
Stefan, yes, just started. Oh, D Stefan, oh my God.
Has a lot of other
I'll send you a link.
Yeah, I mean, we use it. Yeah, we'll keep repeating. I'm Rui, nice to meet you. But also, you're an adjunct associate.
Yes, in my copious spare time.
And David was involved in being involved in that as well.
Although I'll be the South Australian Space Force next Thursday.
Yeah.
So I keep it here.
Yeah. So we try and we do the meetup every 2 weeks. And so usually it's reasonably technical. And then do different types of talks. So sometimes we do ones which are about applications, so they're more user level. And then we like the one that was more, about how you can use the technology. Whereas, say David is involved in standards as well, and so we do talks that are about the Ethereum standards.
I like the idea of what we try to do. Like for me, the way I prepared the talk is where I see the potential to come together and use some. Very often talk about integrating as a way to also be able to communicate decision makers where the person doesn't work. Whereas you have your simplified way of knowing what the person doesn't work. Very often that's the case, right? If people use it,
The world is full of technology that works that people don't engage with. Behavioral economics gives us an approach to try to figure that out. The more explanatory power we have, the better off we are. I'm all for it.
Let's also, like, I had recently interesting discussion very similar on behavioural economics and what we're our engines. There is a huge project nowadays, especially in hydrogen and so on, national grids. This is very often.
How are you? Good, yourself?
Someone sits around.
Pretty good.
Grab a chair and sit down, kind of thing.
I've got a technology paper out early this week, which is really good. Crosschain transactions.
No.
Who's the other guy transaction between two blockchains? South African.
So it's rock, or you can come and talk to
So this is going to be part of
No, we
this.
haven't. She wasn't. She might be coming to Oh, yeah. Oh, the lawyer. Louis. But they found Sandra and David and She said she's going to be here.
The cross-chain transaction, so you, rather than having an Ethereum transaction, just updates one check, does one
So anyway, we'll see what
well,
happens with
rather than do, if we get a value from that check, and assuming I'm happy with that, then I'll execute this transaction. You want to have it autonomously, so maybe.
Oh, okay. So I
There's
see.
a lot of update that happens.
trying to
You want to have them
because
both
they've got
going,
contracts
or need to go
yeah. Look after
We even like sometimes think
but they're the ones that the government is our land.
So you're going through the land
So
law.
we have to go between the government.
All right. So
We've got a contract with the
you'll have to continue this conversation afterwards.
job is to look after.
Hello and welcome everyone.
And,
Okay, so today we've got three talks that are about blockchain research. And so we've got Uwe and Rui, who are from Queensland University of Technology, and myself, who's from Consensus Pegasus, but also doing a PhD at University of Queensland. So I'll actually just pass it straight over to you, Uwe,
Yes.
and you can take
Thank
it
you.
away.
So this is, I think about 6 months back we started to talk about this, and I got asked, you want to talk about distributed ledger technology, blockchain, and how do you think behavioral economics is important for that? I said, well, that's very interesting. We have a project. I can talk a little bit about ideas. And that's what I want to do. So I give you a very, very quick introduction on what I think behavioral economics is and is not. I think sometimes there's been a lot of hype about this term. I recently saw research that says we are just getting off the peak of attention and everybody's frustrated currently that behavioral economics doesn't solve all the problems in the world. But I think there's still a lot to learn, and I really talk about ideas, and if somebody's interested and thinks, ooh, I would like to do more, we're currently thinking about getting a major research grant up where Prime Minister and Cabinet is involved as one partner, and we look for other industry partners that would be interested to think about how we can use behavioral economics to overcome behavioral and economic barriers to the adaptation of new technologies. And I think that's exactly what I want to talk about, where I think economics and behavioral economics can help to more or less lead to the adoption and correct use of new technologies. So very quickly, why do I think behavioral economics is important? What's the best approach? That's the new center at QUT. And then the two ideas developed a lot with Beef Ledger and funded by the Food Agility CSC, and I'll tell you a little bit about that. Warwick is here, and he will definitely tell you what I get wrong. Then I talk a little bit about what I think behavioral economics can offer to you as well, and where I see future potential for research. And it's driven by research that Ramon is currently doing as part of his master's thesis, and hopefully more sometimes close. So what's the idea of behavioral economics? Evidence-based behavioral research that transforms society, and as I said before, how can we use the insights from behavioral economics and the methods to get actually new technologies being used correctly and design them in a way that that they can be used correctly, and how can we use the evaluation, the power of evaluation that economics offers to evaluate what works. I don't want you to do this experiment because I have only 15 minutes, but usually what I would do if I would have 25, would now ask you to go to this web page, and everybody of you would get 2 questions about Gandhi's age when he died. First one would be either was he older than 9 years or younger than 130 years when he died? And second one then would be, how old do you think he was? The interesting thing is, I can guarantee you, I will almost guarantee you, that's statistics, but that the group that I asked the 7 or 9 year question would give me an estimate that's about 10 to 15 years lower than the group that got asked the 130-year question.
Oh, so
right?
it's priming.
That's it's called an anchoring bias.
Anchoring
exactly,
bias,
yes.
yeah.
So this is Struck and Hoopsweiler, who did this research in the 90s, where you got 50 and 67. Nowadays, you usually get about 10, 12 years more, because we know that the Indian life is not that bad, and we are aware that people get older. But it's very interesting. It's completely irrelevant information. You know, Gandhi was older than 9 when he died. You know, the oldest person that ever lived was 131 when he died. Definitely not Gandhi. So it's irrelevant to ask this question, but it influences the decision. Now you can say, well, that's a little bit of magic. These researchers have also done that with criminal judges, giving them a prepared case and asking them to roll a die that they roll themselves. If that ever happens to you, you want your judge to roll a 1 and not a 6. Just like so, what we see from that are 2 things. On the one hand, there are a lot of behavioral influences that are pretty hard for us to predict. I like to do these experiments because everybody thinks, well, it's other people that have biases, and we as economists don't have biases, or we as computer scientists don't have biases, or we as whatever scientists, we are completely free of biases. You can do all of that. That's why I like to talk about the judges. You see, everybody has this type of bias, right? More importantly, you could look at this as a very simple illustration why behavioral economics matters. Because one of the things that I found when I asked the 140-year question, first, I get almost always much closer to the true answer. So when you think about that, the priming or anchoring, as we would refer it, you can actually find out what is the right primer to get better outcomes. And that's a little bit what we try to do. A nudge is the way that it all become very popular. More or less what Thaler and Sunstein says. In whatever situation, I think this is the same for technology, new technologies, or for public policy. They talk a lot about public policy. But whenever you design some sort of environment, technological or in a political matter, you engage in choice architecture. Right? This was just a very drastic illustration, and you should think about and be scientific about what is this choice architecture that you need to then achieve the type of behaviors you want to achieve. So the economists will always say, well, it doesn't really matter. The Homo economicus model of economics would more or less say it doesn't really matter how you present information, because we are also rational and we just absorb it in a very rational way. And therefore the behavior will always be the same. Well, this type of experiments show you it's not the case, and that's what a lot of the research is about. So that you could say it's just design thinking, it's user experience, lots of words where I'm happy to use other words. I think what behavioral economics brings there additionally on top is that we can actually use this economic framework to identify what is first best behavior. Same thing in I think your world. If you design a certain technology, you know what first best user behavior would look like, right? And you know what type of behavior you would like to see. So you have a normative benchmark what good behavior is. In a lot of economic decisions in economic environments, I do believe economics allows you to provide this this benchmark. But it is a lot of development together with people that are context experts. There is this idea to actually get the benchmark, and then you can identify biases as deviations from the benchmark. So that's what we try to do with the new center. I just talked a little bit about the economics to define problems and the benchmarking and people that work in these respective areas. Then you have behavior research to look at that. You can develop solutions, design thinking, and we can somehow start to look at how to find out what works and use a lot of work there. And then there's other stuff as well. We like to talk about that. But that's a little bit the way how I approach problems. The main programs, let me say quickly there. So we do this with a focus on technology. That's Warwick's and Ramon's and Marcus Forth and did Cassandra talk before? Felicity talk before here about the legal aspects. So that's part of it. We have a similar program, interesting, with 3D where I hope, or maybe you find this exciting. We had a little bit of chat before. When I started to talk to blockchain people, I came in as a standard economist, and if you've read this introductory text as well, and at least some people say economics and mechanism design, understanding incentives did play a big role to push blockchain distributed ledger technology, right? So how to understand that people actually do the right thing, how can we design a mechanism to avoid that people cheat. I think that's part of the research that we try to do. In particular, at the moment, what Ramon is working on is understanding the first bit of the food supply chain. So beef ledger, the way I understand it, Warwick may correct me, is a lot to try to harness distributed ledger technology to actually increase the value that this food supply chain can offer and ensure food provenance. So part of that chain would be how do you get cattle from the farm to the abattoir, and how can you use potentially distributed ledger technology to get the incentives right there. Now, what are the interesting questions? Economists would say in some cases you actually can write very good contracts that provide the right incentives for truck drivers to drive carefully with the cattle. In other cases, maybe better to add some sort of monitors that could automatically record into the blockchain data about the behavior of the driver. Right? So the research is a lot about how do we best set that up, and I do hope one of the implications is, and one of the open ends where I think then some of you potentially can come in, is to think how to implement that then further, right? So it's this, the economists are only good to say, to try to identify how do we get the incentives right, what is necessary. I think then we will rely on you, hopefully, to get it out there. And then as a long-term perspective of that, step actually to see what actually works, what is accepted by drivers. If you think about privacy, or they say, well, I know that I sometimes speed on certain parts of the way, and some sort of driving monitor will stop me to do that. Well, if they only speed on parts of the way that are particularly well built up, maybe that's okay, right? And we should think about that, and that's part of, I think, what we try to do there. And then later on, hopefully, work with an implementation there to evaluate what works. The second half is actually even more on the incentives, and it's a little bit more in the design phase, is to think about food provenance and what happens at the other end. A lot of beef ledgers, beef goes to China, where people worry about copied food or manipulated food, not properly kept food. But it's really sometimes really just replacing food. So good Australian beef with, I think it's Indian buffalo, if I remember, that looks somehow similar at first, but is not the real deal. And it's important how they have to try to understand how do the incentives need to flow. It's not that easy, because very often we start to think, as for Bitcoin, I think where a lot of the inspiration came from, you do pay with the beef coins to the suppliers, but is maybe for food provenance is much more important to actually get people to record what they have taken or not have taken out of the chain, right? So one way to avoid that food miraculously duplicates because you add a couple of buffaloes to the mix of the beef, is to somehow keep track of how much of that is used, right? So that part of the project, as I said, is a bit more in the future, is all about trying to understand what are the incentives, how can we design that right. Then again, we would hope that we can look at data to actually document what happens there. So what do I try to say here? And I'm almost done. I think where do I go with time? Is it about right? It's all right. Good, good. So a lot of the type of behaviors that we look at and where I see technology as well requires trust of humans and correct use of that, right? So we do have with, I think, blockchain technology something that tries to give you some sort of idea of truth. Sometimes you hear about truth zeros in this case. And very often it's the case that we don't necessarily need to understand the technology. I think most people in this room understand distributed ledger technology. I do feel I understand it, but I also know that many other people that you meet somewhere else don't really understand it. I don't think that's a problem because we don't understand our cars and we are able to use them, but we trust them, right? So this type of trust element would be one of the ones that are very close to what the behavioral economist wants to look at. I think the other thing that I try to indicate with this second point is that I think behavioral economics as a tool can give us a way to document what works and understand what works, and therefore move us forward in dealing with it. So in case you're having solutions where you wonder how can we evaluate that, I think behavioral economics may be a good way to do that. And what I like as an economist with it, compared to what economists have done for a good part of my career, is it's a relatively easy way because you usually have a control and treatment group perspective when you look at data to communicate it with decision makers. So before, economists have usually done big models that only economists really understand, and you have 3 economists and 4 opinions on the same type of data. Here it's really very simple comparisons, just as a tool. So it may be interesting you want to study this a little bit more I would be keen to have that discussion, and there are a couple of colleagues that will be keen to do that as well. The experimental approach, I think I don't need to explain much of that. It is really this idea that you could look at different designs and use them and see whether you observe the right types of behavior. We do that in real world situations. I think the hope with the work with Beef Ledger is that we end up there, but we have done work with the Australian Tax Office, with Suncorp, with a couple of government and industry players, using just simulated environments, and more or less using that to inform and compare different types of solutions. This gives us some sort of idea what really works, what's the causal relationship there. And that's it. Get in touch if you want to find out more. Maybe sign up to our list. We do, if you find this interesting, we do organize talks where you can learn about applications of that from a pretty broad range of topics. Thank you.
Thank you.
Thank you. Thank you very much for receiving me today. My name is Will Oliveira. I'm currently with QUT. This research was done when I was at UQ, and it's done with some colleagues from there and from another colleague from the United States. This is our first, or it was our first step of something that we are interested to understand, and our discussion today, or what I'm going to present today, is going to be a little bit more maybe macro, and not so much like you guys had the opportunity to explain, that you can experiment. What I'm going to talk, it's going to be about what we believe that's going to be the future, or how we see the market changing because of blockchain. And I believe that this is important, or we believe that this is important, because what we see today in the market, in the industries, might change. And if this change happens, as we believe, many of the things that we might be doing might not be useful then. So let me try to explain a little bit more what we have in mind. So this is ancient times, right? Where the market was really a market, where you almost don't see any corporations. Maybe there was some kings, but in the end, there were no corporations as we know today. And they didn't need any corporations. They just need a market. They produce goods, they want to sell, they go to the market, someone goes there and is willing to buy those products based on income that they made elsewhere in other products. So this was the market, again, without corporations, or very limited number of corporations, companies. Well, this starts to evolve, where many of these now markets starts to have corporations on it, right? So these brands, companies selling to the consumers. And these keep evolving to a mall, shopping mall, where again, almost now, you have corporations selling to customers. So there was this evolution from individuals to individuals, using the market as the selling point, to having corporations selling to individuals. So this is history. And this is today, where the markets are online, as you know, in this case, Taobao or Amazon. But again, corporations, or many of them corporations, selling to individuals. Interestingly, however, these digital markets are starting going back towards the ability of individuals being able to sell to individuals, particularly the case of Taobao, even if under a corporation. So the market is changing again. Quick history. So Adam Smith, almost 300 years ago, said that the key of an ancient perspective is found in a free market. And the free market, we know that it is the best mechanism that we know today to allocate productive resources, people, and capital. Further on, Coase in 1937 explained why. So if the free market is the best way for us to allocate people, resources, capital, and so on, why do we have organizations? Why do we need companies? We shouldn't have the necessity to use companies. So we researched on that, and he came up with 4 explanations why we need corporations, or why corporations exist today instead of just individuals trading with other individuals. And the first one is the cost of search. It's costly to search where is the best product that you want to buy, right? In the markets that we see, the ancient markets, if there was only one person selling a belt, there is only one person that sells belts. Nothing you can do, right? Then you have the cost of contracting. So it is cost for you to always, buy from individuals. So that's why sometimes you want to do it internally. You don't want to outsource everything. So that's another reason why you have corporations. There is the cost of coordinating all these buyers that you need for your production. Imagine that you want to build this table, so you need a lot of things to buy the table. So you need to coordinate all these suppliers. So that's why, again, sometimes you want to do some of these parts internally. And then there is the cost of establishing trust. Right? Many times, even if you have contracts, you don't have enforceability of the legal. Case in point, even if you have a contract in China, and I worked there for 10 years, doesn't mean anything, because people can just not keep their word, and what are you going to do? Nothing, because there is no enforceability of the rule of law. So these are the 4 main and important parts that why we have corporations, why we do things inside corporations instead of we outsourcing everything. Willism, after that, explain why this happens, and it has to do with opportunism. So people have opportunist behavior where they can they try to be opportunistic, particularly in markets, like I said, where the rule of law or the enforceability of it, it's very, very small. So, for us, what was interesting about blockchain is that, wait, blockchain might change some of these assumptions that we have here. Some of this cost of search, cost of contracting, cost of coordination, and cost of establishing trust, maybe blockchain might change some of these things. And then we question ourselves, in the future, can blockchain reduce the number of, or the need of corporations that we have in the market? Because if that is true, then the way that we operate as individuals or within firms will change dramatically. So this was our question. And I don't want to explain what blockchain is, because you know much better than I in terms of the technicality of it. So what motivates us is that, wait, we might be looking in the future to a completely different market that we have today. So we call to this new field of research organizational democratization. That the aim is to see how blockchain can enable enterprises and traditional institutions, and how can we organize firms, companies, and individuals in a society. Now, looking at each one of the explanation Wyckoff used for why we have corporations, we explain how blockchain adds or bring credibility and reduce these costs. Because, like I said, if that is true, then in the end you'll see, we question ourselves, do we need so many organizations as we have today? But let's go one by one. So the first one was the cost of search for finding the right information, people, and assets. As we know, internet, even without talking about blockchain or whatsoever, internet reduced that significantly. There is, however, these days, a problem of quality of the information that you can get from the internet, right? Reliability, fake news, call it whatever you want. So what blockchain can bring is, can add credibility through the sheer amount of, people that believe that that information is true. The second question was the cost, or the problem was the cost of contracting between independent economic agents. So with smart contracts, for example, from blockchain, what we are observing is that we can have contracts without having the institutions, meaning the regulatory, legal, and enforceability, that we today use when we establish a contract. Even you as an individual with your company, right? The third one was the cost of coordinating autonomous economic actors. So what we believe is that, again, with blockchain, we can decrease that by identifying, legitimizing, and coordination specialized economic actors can be extremely reduced. For example, the supply chain parts, when you have a global value chain, using blockchain can reduce a lot of the work that you have to do. And finally, the cost of reducing uncertainty. As we all know, this is one of, in our opinion, one of the most important parts that blockchain can do, because every transaction is recorded in the public, and doesn't need to be in the public, as you all know, but can be in the public as well. So we come along with this, we academics like very much 2x2 graphs. We come along with this way of looking at how blockchain and transactions can influence each other. So we have different levels of automation that goes to high and low, and we have complexity. And in each one of them, blockchain will have a different voice, will have a different, can have a different type of actions. But what we are observing is that blockchain can act in each one of them. And if that is true, and here are some examples. So here, for example, we have the real estate contracts that we will not need banks escrow accounts or notary, for example. Here we have cheaper and faster financial transactions. As you know, we are going towards still, in my opinion, in the beginning, but we are going towards getting this more efficient and reliable. Well, we have organizations with lower level of structures, and this is where we are going towards in terms of our research, and I will talk about that in a minute. And then in terms of complexity, we can reduce a lot the supply chain in terms of how we can close and enforce contracts in a much easier and faster way, particularly with suppliers. That is very much straightforward. So, as a conclusion, we believe that blockchains will change a lot the way that we see organizations, the way that we need institutions. We believe that institutions will not disappear, but they will. And we know by fact, the other day I had a meeting with the government of Queensland, and many of the organizations and institutions, so government institutions, are working towards how it's going to be in the future, where many companies or individuals don't need institutions for do their transactions, and they are worried. For example, your driving license, for example, it's a case in point, and we are working at the moment with them on how the future will look like for them to be prepared for that. So even if they will not disappear, we believe that they will change dramatically. We believe that blockchain itself will need some kind of regulatory, and I know that this is a bit against the sense and of blockchain, but we believe that we might need some rules of game on that. But what we believe is that many of us in 50 years time might not be working for a corporation as we are doing today, because we don't need that. Because we can do our job, we can do what we are good at in a much easier or in a different contractual way without the need of corporations. And that's what I have for today. Sorry about this a little bit more macro perspective and not so much in-depth and technical, but this is where we are. Thank you.
Great.
Oh, I'm sorry.
So, do you know Al Robb and Fiona Rode over at UQ Business School?
Yes, I know that.
So Al and Fiona and one of our consensus colleagues, Shahan Kashkadorian in Toronto, and myself, wrote a paper last year identifying transaction cost economic perspectives of different forms of blockchains.
I read the paper.
You did. I would love your comments on that paper. And if we should, probably if you and Al and I, sounds like should get together for a coffee and have a conversation, and maybe
definitely,
maybe out of that will come some of the next work.
Sure. Martha, that is my colleague in the paper, she's the head of the information system department where Al is part of. And yeah, we had a conversation.
I just don't know how we haven't met yet.
Yeah, that's true. But yes, definitely, and Al knows me. It would be my pleasure to give you feedback. I read the paper a long time ago, but I still remember, and I would be lovely. I would be delighted to.
Yeah, we should get together and chat.
Sounds great.
Cool.
Thank you.
Oh, well, that's what the meetup's all about, bringing people together.
It is.
Okay, so I'm going to talk about atomic cross-chain transactions today. And so, look, I've been the driving force behind a lot of the ideas that I'm going to talk about, but this work has had many contributors, and in particular people highlighted there in bold, but also many others. So it's 40 pages long, but hopefully it's enough for people to think about, learn about, and comment on, and consider even implementing if they did so wish. So with atomic cross-chain transactions, what you're really trying to do is you're on one blockchain, and on another blockchain you've got data that you might want to get, read the value of, or maybe you want to be able to update, or maybe there's functionality that's available somewhere else. So maybe in software, those, say you might write, say, a Java class, so some code that does some functionality. And normally you might have another Java class which might call that. So you might write some code which calls some other code. So you've got that functionality and you want to reuse it. And so in the case of blockchain as well, you might have that functionality might be on a blockchain that has specific data available to it. And so you might want to use that data and the functionality that's available in that blockchain. So that's why you might want to do cross-chain transactions. And all of this is related to sidechains. And so a sidechain is just a blockchain. But it's a blockchain that uses another chain or references it for some reason. So it needs to have that to provide capability, functionality. It has a reliance on it. And so it could be for security reasons, so for pinning. So in other words, you might pin the state of the chain. Or maybe you need it for addressing information. You want to use it as lookup. Or maybe you have some sort of shared state. And this last one is what we're using it for in this case. And so these Ethereum private sidechains, the idea is you have ephemeral, on-demand, permission private confidential chains. So ephemeral means that they are created, they are used for about a time, then at some point you don't need them anymore, so you archive them. So a lot of the blockchains at the moment, they're going to live forever. Well, that's not normally how things happen in the real world, where maybe you want to do a contract, you want to sign a business contract, you want to get a letter of credit or something. The whole thing might be done and dusted in, say, 3 months or something along those lines. So you want to be able to create it, have it run, then archive it, and maybe bring it back from the dead if you need to later on. On demand means that when you want to create that blockchain, you want to be able to do it like nowish. You don't want to sort of say, hey, let's try and configure this blockchain and it's going to take a week. You want to, like an SSL connection or HTTPS connection, you just want to type it in, bam, it's up. And so that is what we're aiming for. Permission, you're only letting a limited number of people join the network, so people that you're agreeing should be part of it. Private, you're going to not display all the participant information, maybe hide some other information about the transactions, and confidential, you want to encrypt stuff. So in Ethereum, we've got transactions and we've got views. So transactions are function calls which they don't return a value, but they update the state. And so they execute on the network, so they're mined. You hear about these miners, so the miners mine transactions. And so you could do a value transfer, or you could deploy a contract, or you could be doing a function call on a contract. A view, on the other hand, returns a value, but it can't update state. And so it executes locally on the node that's near you. And it's a function call. So you could do a function call and it returns a value. So that's a view. So cross-chain transactions, what we want to do is you have an app, an application, and it fires in a transaction which is going to do other calls, other transactions, essentially. So we have the originating transaction which goes in, and so you call cond buy, so conditional buy, and it goes and it says, all right, well on this other side chain, for this contract, call that function. So it calls rate and it says, give me the rate back. And if the rate's less than 100, then I want to fire off a transaction over here, which is going to update some state, and I want to update the state here. And so that's what a cross-chain transaction is all about. It's about getting values back from a different chain, but also updating state across chains. And the big thing about that you need to be able to do is you need atomic behavior. So in other words, you want this chain and that chain to update or not. So you want the values on the updates to be committed on both chains or to be ignored on both chains. You don't want to have half committed, half not committed. So we've got originating transactions. So that originating transaction that came in, it can fire off subordinate views or transactions. The subordinate transaction similarly can fire off more, so you can cascade down as many depths as you like. Though there may be some practical limits to this, which we're currently researching. There are also subordinate views, and so a view can call another view, which could call another view, because remember the views are the things that are returning values, and so the current behaviour is that a view doesn't update the state, so we want to keep that Ethereum behaviour of not updating state in a view. So one view can call another view, which returns a value, but you can't update state. So let's think about enterprises. So enterprises could run a multi-chain node. So we've got the idea of a multi-chain node, I think, yeah. So a multi-chain node is a logical grouping of sidechain nodes, so blockchain nodes. And so enterprise says, all right, I'm part of all of these sidechains, and also this coordination chain down here. Other enterprises may not be participants in all of the different sidechains, or they might not be part of that consortium or that grouping. And so you might have this sort of setup where these two parties are part of that sidechain, and they're all part of the coordination chain, but there's not a lot of overlap. And obviously, you can imagine you may have many enterprises with a varied relationship. The big thing to think about is that though enterprise A is across all of those sidechains, the other enterprises are not. And though when you're doing a cross-chain transaction, the enterprise that's going to have that application doing the function call needs to be across all of the sidechains that are part of the actual function call graph. So when you've got a function call which calls another function which calls another function, they're going to be going across chains, and all of those chains have to be included in the multi-chain node. And all of the multi-chain nodes need to be on this coordination blockchain, and that's to allow you to have some cross-chain state, essentially. So imagine we've got this set of function calls, or this set of call graphs. So we've got an originating transaction comes in, which does a view, and that view needs to call these other two views to get the results, and then you have a transaction go in. So imagine that is your call graph. So given this set of nodes and the sidechain nodes and Ethereum and multi-chain nodes, so if you're on sidechain, if you're on an enterprise C here, so let's look at sidechain 2. Sidechain 2 is here, it's getting results back from sidechain 3 and 5. However, enterprise C isn't on sidechain 3 and 5. So it needs to be sure of the values that are coming back, even though it's not on those sidechains. Also, it's on sidechain 4, so if we quickly flip back, sidechain 4 does a subordinate transaction. But you notice though that enterprise C is not on sidechain 1, and it only wants to do its update if the update on sidechain 1 happens. So it wants to have atomic behavior. And similarly for enterprise B, it really only wants sidechain 1 to be updated if sidechain 4 is updated, and yet it's not even on sidechain 4. So how's it, but it needs to be sure that that update has occurred. So how we get over this technological problem is using, it is to prove values across sidechains using something called threshold signatures. And so the idea is that you can use threshold signature schemes to essentially split a private key into multiple parts. And so imagine we have A, B, C, and D, and they each have a share of a sidechain. And they've got some data which they can each threshold sign, so they each sign the parts. And then you've got threshold signatures. And then you have a mechanism of combining any M of n. So n is 4, because we've got 4. You might say, all right, well, if we have any 3 out of those 4, then we're going to have a threshold signature. And so maybe sidechain 3 doesn't agree, this one here, the C, maybe it says, I don't agree with what you want to sign. I'm not going to be part of this. Well, if you've said that we only need 3 or 4, then you're going to have 1, 2, 3 will still sign, and you'll still have a threshold signature. Or more likely what would happen is that sidechain B might be uncontactable, or something like that. So the idea is that you use that to create this threshold signature, which then allows you to be what's called Byzantine fault tolerant. So even if you've got either a malicious actor or an actor who's gone offline, you can still have a value. And this actually mirrors what you see in consensus protocols, where you have essentially a threshold of actors agree on something and then it happens. So that threshold signature can be verified using the sidechain public key. The important thing about this sidechain public key is it is a combined key of all those keys there. So it does not indicate, so the signature doesn't indicate who signed, and this key doesn't indicate who the actors are down there. So it's so it's not like your normal ECDSA signature. It's a something quite different. So we store that sidechain public key in the cross-chain coordination contract on the coordination blockchain. So the coordination blockchain was that one down the bottom that they're all on. And so you split up your validators on your sidechain, and so you've got your end validators, and each of them's got a private key share. And as long as any M of those of those validators sign, then the data they sign can be verified using the public key. So sidechain 1 is your originating sidechain, and all of the nodes down here in multi-chain node A are what's called your coordination nodes. So I know some of you are thinking, oh, this is sounding centralized. We've got an originating chain, and we've got coordinating nodes. So it's per transaction centralized. So it means for that one single transaction, this is the originating chain, and these are the coordinating nodes. However, the next transaction could be, say, across sidechain 2 and 4 and come in here, and then in that case, these would be the coordinating nodes. So it's per transaction centralized. And so the coordinating nodes, they coordinate with these other nodes on the sidechain to threshold sign a value. So that's how you can do it. So sidechain 3, if it needs to prove something to sidechain 1, the validators on this sidechain threshold sign something and then give it to sidechain 1. Sidechain 1 can then obtain the public key out of that coordination contract that's down in here and then verify the value. So this protocol is defined over 40 pages of a pretty dense paper. So I'm just going to talk you through the 5 messages that are sent between the chains, because I think they're quite helpful and informative in how the overall thing works. So we have a start message, and so the idea is that this node here, the coordinating node on the originating sidechain, puts that into the coordination contract on the coordinating blockchain, and it says it started. So it had to work with the other sidechain 1 nodes to threshold sign it. They're all agreeing that they're happy to start this cross-chain transaction, and then they put it up. And they also, when they're doing that, they essentially uniquely identify the cross-chain transaction by the combination of the originating sidechain ID, a cross-chain transaction ID, which is a random number, the cross-chain blockchain ID, so essentially which cross-chain blockchain are you doing? Really? That should be coordination blockchain. I'll write that one up. Anyway, don't worry about that. And also what the contract is, the coordinating contract is. And the big thing that you've also got is a timeout. And so this timeout is measured in blocks on that coordinating blockchain. And so this is a global view timeout that is used by all the sidechains. So if you were calling, so once one of them is posted to that coordination contract, then the cross-chain transaction has started and we're off and going. To get a result back from one chain to another, you have the subordinate view result messages. So you have the subordinate view gets executed, and then the result of it gets threshold signed and then sent back to the calling chain. And it has information which is essentially uniquely identifies it, the sidechain ID of the sidechain where the view is executed, the block number which it's executed on. So when did it execute? So all the nodes on that network have to agree, well, what is the return result for that block number on that sidechain? And what's the result? And then transaction ready. So when you have put a subordinate transaction down into a sidechain, the act of that transaction being mined locks the contract. So we've introduced the idea of contract locking. And so once a contract is locked, then it's locked until it is either the overall cross-chain transaction is ignored or committed, and or timed out, which ends up meaning that it's ignored. And so the nodes, the coordinating node, works with all the other validating nodes on that sidechain and says, all right, well, we've mined the transaction, that contract is locked, now let's tell the originating sidechain our subordinate transaction is ready to roll. We're ready. And so they work together to sign this message, subordinate transaction ready. Yeah. And so it again has the unique information about the cross-chain transaction, the sidechain ID of the sidechain that the transaction executed on, and its transaction hash. And then finally, or the fourth one, there's also an ignore message. So if something bad happens and you know that the transaction is going to fail, you could create an ignore message. But assuming everything's going fine, you create a commit message. So this would be that coordinating node on the originating sidechain would create this ignore message, not this commit message, because it's got the transaction, subordinate transaction ready message for all the subordinate transactions. So it knows that all of the subordinate transactions and all of the other sidechains are ready to go, ready to be committed, and it knows that the originating sidechain one is ready to be committed, and so at that point it works with the other nodes on the sidechain one to threshold sign the commit message, signs it, and then it puts it up into the coordinating blockchain, and then at that point the message is committed. We're all done. And that says the same thing. All right, so for those of you who are interested in Pantheon and where we're up to, work in progress. And in fact, if you want to join the team to help make it work in progress happen a little bit quicker, have we got a job for you? We're actively hiring. So I've talked about Ethereum private sidechains, but this technology could be applied to other blockchain technologies, for instance, Fabric, or Quorum, or a huge range of technologies. We're initially obviously just going to focus on our own technology, the Ethereum private sidechains and our privacy group technology, and get it in there. But there is no reason why this couldn't be applied across different permission private chains. We need to do further research to look at public chains and proof of work, proof of stake style chains, and work out the applicability there. And that is the end. So whilst we're thinking about questions, I'll just put up, these are the forthcoming meetup events. So are there any questions for myself or the other two speakers?
So Peter, will that be in the next release of Pantheon?
No.
I don't think so.
No, that is research at the moment, and so we're actively working on creating a POC that we'll have internally, but there are incremental steps moving towards that technology, and but in the fullness of time you will see this style of technology come out. That is the plan. I think at the moment we can't say exactly when. I think that, but you certainly should at some point engage again with the product management people from Pegasus and say, where are we up to? I know we've released 1.1 earlier today? Earlier today, yes, team. And 1.1 comes out with some fantastic features that someone else can tell you all about, because I'm not going to try and do it live streaming in front of a camera. because I'll probably forget some critical feature, and then half the room at the back will throw stones at me. So.
Privacy, permissioning, fasting.
Okay, privacy, permissioning, fasting. Thank you, Chris. Yeah. Yep. Are there any other questions for myself? Or? Okay, well, look, thank you everyone for coming along today. It's been, I think it was great listening to those two talks, and so thank you. Thank you. Coming along.
I don't even know what it
Yeah. Yeah. I'll just stop the live stream.